Well, you've made it to the end of the week. It's Friday. Yay! Today we're going to talk about permutations, which just about wraps things up for our particular chapter. On Monday next week, we'll do a little quick review session. And then on Tuesday and Wednesday, you'll have 2 days to complete your unit test. So again, this is it. So permutations, what are they? All right, just like combinations, they show us how many different ways we can combine things, except for with permutations, the order does matter. So we'll talk about what makes the order matter and why that's different in a second. But the formula looks pretty similar to yesterday, except we don't use that C, we use this P instead for permutations. Everything else is the same. The N is the same, the R is the same, except the fraction's a little less work. If you remember, the combination formula had an extra r factorial in there with it in the denominator, but we've taken that out for a permutation. Other than that, it's pretty much the same type of work. These actually work out a little bit nicer and easier. That's why I saved them for Friday. All right, so let's look at an example. Let's say you've got 3 people named A, B, and C. All right, and we need to pick a grand prize winner and a second place winner. So we're going to have these 3 people, and somebody finishes first place and somebody finishes in second place. Well, one way we could have it is we could have person A finish in first and person B finish second. Or person A could finish first and person C could finish second. But there are no other ways for person A to win. But what if person B wins and gets first place? Well, then A could be in second, or B could win and C could be in second. And I want you to see that these two are different because the order matters. And the one on the left, A was the winner and B was in second place. Whereas the one on the right, B was the winner and A was in second place. And that's a different result. So again, since the order matters, these repeats count. We should have bigger answers. All right, then the third option is to have C be the winner. A could finish second, or C could win and B finishes second. So again, that's doing it the long way. We don't want to do it that way, but I wanted you to see the difference. Yesterday, when the order didn't matter, we would not have counted both of these. Again, when the order doesn't matter, I need 2 people to come help me carry boxes. I want person A and person B, but if I pick person B and person A, that's the same group because the order didn't matter. But now that the order does matter, the problem changes just slightly. So let's do some examples. All right, it says there are 8 runners in the 100-meter race. Sounds like the Olympics or a track meet or something. How many different ways can we award medals to first place, which is called gold, second place, which is called silver, and third place, which is called bronze? And the order matters. Finishing first is different than finishing second. So that's why it's different than the ones yesterday. The order that they finish does matter. All right, so since the order matters, it's a permutation. There are 8 people running in the race, and we are paying or giving medals to the top 3 places. If you finish in 4th, 5th, 6th, 7th, or 8th, it doesn't really matter. You didn't get a medal. All right, so the rule says what we're going to do is the n factorial, and if you forget, the n is 8, and the r is the 3. So that's going to be n factorial in the numerator. And then the denominator, it's n minus r factorial. So essentially 8 factorial over 5 factorial. So let's write it out, simplify. So 8 factorial is 8 times 7, which is that's a terrible 7. 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And the denominator 5 factorial is 5 times 4 times 3 times 2 times 1. And we want to cancel out all the matching numerators and denominators, leaving us with just 8 times 6, or 7 times 6. If you multiply that out, that's 336 different ways. That is a lot of different ways that we can have those 8 runners finish if we're only worried about the first 3 places. Again, we're not worried about place 4 through 8. That doesn't really matter. But 336 different possible combinations of first, second, and third place. Again, the answers get a little bit bigger today. Let's try one more. There are 10 members on a basketball team. The coach needs to choose a captain and a backup captain, just in case the captain is sick or something like that. So it's usually called a co-captain. How many ways can he, she select these roles? So the coach, whether it's a girl or a boy, has the same job. You pick a captain, that's like, a certain person, and then a backup. And those roles are different. It's not the same to be the captain as it is to be the backup. So again, because the order matters, being the captain is different than the backup, then we are going to use a permutation. There are 10 people involved, and we are selecting just 2 out of those 10 people. All right, so again, that means my n is 10, my r is 2. So my formula says n factorial over n, whoa, I started to jump ahead, over n minus r factorial. So that means in the numerator, we're going to count from 10 all the way down to 1. 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And then denominator, 8, or 10 minus 2 is 8, so start with 8. 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And then cancel, 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 cancel. All that's left is 10 times 9. There are 90 different ways that the coach can choose his captain and backup or co-captain. All right. Hopefully this is following enough of yesterday's work that it's pretty simple for you. Again, the hard part is deciding which one of these to use in certain situations. I'm kind of set it all up for you today. All right, good luck.